at this time, I'd like to welcome everyone to our first session of this series, and I'd like to introduce John Axe, who will introduce our speaker and our session for today. Thank you and welcome.
Welcome to the first of 6 Tuesday morning talks of the summer sessions of the ILR. For those of you who are watching remotely and who don't know me, my name is John Axe, and I've had the privilege of inviting speakers for the ILR for a number of years. But let me tell you a little bit about how this series came about, because it was unusual in a very nice way. We often put series together one talk at a time, hoping for, or at least inventing, some overarching theme. This series started because I heard nice things about a physics department seminar that was given early this year by Professor John Block from the Florida Museum about the circumstances that were responsible for the end of the age of the dinosaurs. So I contacted him by phone, and he said he'd be glad to do this, but I would have to work through his scheduler, Brittany Snipes, at the museum. When I contacted Ms. Snipes, giving her a range of dates, because Block was the first of a number of speakers that we were hoping to put together, she asked if I would like suggestions for other museum speakers as well. Well, to shorten a longer story, I said yes. And so the thanks for the 6 talks of this series go entirely to Brittany Snipes. So Brittany, if you were watching, thank you again for doing a wonderful job. The speaker today is Dr. Nick Gauthier, who's the Associate Curator of Artificial Intelligence at the Natural Museum of Natural History. He's going to make clear what artificial intelligence is in his talk, I hope. And he has affiliate appointments with both the UF Anthropology and Geography departments. He received his PhD from Arizona State University. But before coming to UF, he also had appointments at the University of Arizona, working on hydroclimate variability on the Western US, and at the Scripps Institute at San Diego, working on reconstruction of the climate during the domestication of rice in Southeastern Asia. The subject of his talk today is how societies have either adapted or failed to adapt to climate changes across diverse regions, cultures, and time periods. And the title is Putting People in the Earth System. So please welcome Dr. Nicholas Gauthier.
The title of my talk is Putting People in the Earth System. So first I want to talk about what exactly is the Earth system. So it's this concept recently developed by climate scientists to encapsulate all the different processes and interactions that control climate and the environment on our planet. So it's not just the atmosphere, the oceans, the land surface, the ice sheets, and the biosphere all continuously acting and interacting with one another generates what we call the global Earth system. And it's basically recognizing that it's not easy to just peel apart climate and environment, vegetation, animals, that they're all part of one continuously interacting system. All right, so Earth system right here. And so it's a really complex topic. You know, you can think about the weather, the climate, the environment at any point in space at any given time. And so a useful way of thinking about the Earth system in a way that we humans can understand are biomes, which you probably learned about since elementary school, that biomes are these emergent combinations of particular climates and environments and vegetation that we can divide the Earth's surface into. So you have tropical rainforests, deserts, Arctic tundra, savannas are all biomes. They're these combinations of different processes and patterns in the Earth system that are stable over time and space. And so the one thing missing from this traditional view of biomes that we're all familiar with are people, right? People have transformed most of the Earth's surface, at least recently. That's the whole idea behind, if you've heard the concept of the Anthropocene, that today people are the dominant driver of change on the planet right now. And so the traditional view of biomes leaves out this really important variable. And that's crucial because Earth's surface has been transformed by what we can call anthropogenic biomes or anthromes. That is, they're like a biome, like a natural feature of the landscape, but that reflects some influence of humans. So you wouldn't call this landscape a jungle, right? You would call it a farmland, farm field, a rice paddy. You can see the influence of humans. They've physically altered the hill slope here, so changed how water's flown over it. We've changed how water is collecting here. We've changed the kind of vegetation that's growing. And that's going to affect how temperature and moisture flow between the land and the atmosphere. It's going to release methane and other gases into the atmosphere that weren't previously there. And so even this relatively small scale human influence has this really large scale effect on how the Earth functions. And so we can think of these anthropogenic biomes or anthromes as varying along two different axes. So one is population density, that is how many people are on the landscape at a given place. And the second is land use. So it's what are those people doing on the landscape? So an obvious anthrome would be a city, an urban area that's continuously built up, that's changing how water flows across the landscape, changing what kinds of animals can live there, and even changing the physical climate of that area. You also have smaller scale anthromes like agricultural villages that, even though they may not be as transformative as an urban area, still have a really marked impact on their local environment. And then as you decrease population density, you get other kinds of anthromes like cropland, grazing land or rangeland, and somewhat more difficult to understand, but also lots of woodlands. Lots of places that we think of natural forests are actually second growth forests that have regrown after people cut down the landscape. And they show influences of people burning fires or hunting or herding animals, these smaller scale influences that still change the physical landscape in a perceptible way. So these are all different kinds of anthromes that we can see when we look across the planet. So there's this lingering assumption that a lot of us have in popular culture that this transformation of the planet by humans is mostly recent and inherently destructive. That is, it's a product of the Industrial Revolution and mechanized agriculture. We do insane things like irrigating vast swaths of the desert or cutting down trees through deforestation. And that this leads us to this faulty mindset. If we want to conserve nature and conserve biodiversity, that all we have to do is just get the people out of there, right? Go back to what it was like before. And there could be nothing further from the truth. So that's the point of this talk today, is pushing back on this notion that human transformation of the planet is mostly recent and inherently destructive. And to do that, we're using this wonderful data set called HYDE 3.2, developed by these researchers in the Netherlands. And this is basically a continuous map over the Earth's surface of where people were living and what they were doing with the landscape. It uses this complex set of rules, basically boils down to looking at geographic features of the landscape. So like, are the slopes shallow enough to grow food? Are you close or far away from farmland or water? And then using modern day population distributions and pushing that back in time over the last 12,000 years. So this is how people are represented in climate models, for example, of the past. You have these kinds of spatial maps. So this is just an example from the HYDE data set, Reconstructing Cropland. This is Eastern Mediterranean. You can see Cyprus there. On the bottom left is Egypt and the Nile Delta. And so you get these nice maps of where people might have been farming in the past. So we could go starting here at 3000 BC and moving closer to the present. The problem is that this is just a huge amount of information that's really difficult for us to understand. It doesn't have this clean divisions that anthromes or biomes have that we can use to understand how these changes occurred over time. So what I want to talk about today is this paper that we did recently out in the Proceedings of the National Academy of Sciences, taking this rich data set developed for climate modelers and trying to put it in a way that we can understand in order to map out these anthropogenic biomes over space and time in the past. And so to do this, we use this global hexagonal grid system. I love talking about this, but I will spare you the details. Basically, this makes it really easy to do mapping and analysis on a global scale. Most maps get distorted as you move closer to the poles, These equal area hexagons allow you to do really fine scale analyses on a large global domain. So we divided the landscape into these hexagons, extracted this data about where people were living in the past and what they were doing with their farming and grazing. And then we ran it through this classification system. Again, this looks complicated, but basically what's happening, we have different thresholds of population density and land use. So if we're starting from the top left, we say if a given hexagonal grid cell has more than 20% of its land area covered by urban area, or it has a high population density, we call that an urban anthrome. We move down, you have slightly fewer people, but lots of farmland. There's some kind of village, so a rice village, irrigated village, rain-fed village, so on. As population density gets lower, you have what you would normally think of as croplands or rangelands. And then down here at the bottom, you have these cultured anthromes, we call them. So those are places with very relatively low population density, but still some influence. So think of like a national park or something like that. It's technically there's not a lot going on there, but you have this continuous flow of people moving through the forest and affecting the landscape. And then at the very bottom, you have these true wildlands, so places with no people or no human activity. So in this data set, we take these reconstructions of population land use, we get our hexagons, we extract the data to the hexagons, and then we classify them into the anthromes. So you can immediately see how the anthromes help us understand all of this complex data in a map on the left here in a way that's much more clear. So you can see, for example, the Nile Delta there is covered with these irrigated villages. And as you move further north into Israel, you have more rain-fed villages and so on. So we did this approach for the entire planet for all of the last 12,000 years. And this is the result. This is the present day distribution of anthropogenic biomes on the Earth's surface. And the one thing that you can immediately see that stands out is that almost all of the Earth's surface today is transformed by humans in some way. These wildlands here on the bottom, these little showing up in white here, are only present in like the far Arctic Circle, in the Sahara Desert, and the Australian outback. Everywhere else on the planet has been influenced by humans. Even the deepest portions of the Amazon rainforest have had some influence from humans today. Now we can take this analysis and push it back in time. So what you're seeing here is each of these columns is looking at the distribution of these different anthrome types over time. And so this is a time step here, moving from left to right. And as we're moving from left to right, we're zooming in time. So this is thousands of years, hundreds of years, and then decades on the far right. And this red line is looking at global population. And so what you can immediately see, first of all, is this large-scale shift in the last 50 to 100 years with mechanized agriculture and the resulting boom in global population. But you can also see that even back here 12,000 years ago, most of the Earth's surface had some human influence. These brown categories here are what we call the remote woodlands or inhabited drylands. These are these sparsely inhabited places that had, mobile hunter-gatherers moving through forests or deserts, burning the landscape, gathering food, hunting animals. So even 12,000 years ago, most of the Earth's surface was like that. And this, what's showing up in white here, are the true wildlands. So that's the deserts, ice, tundra. And that area has stayed mostly constant for the last 12,000 years, which is to say, there really is no such thing as a pristine wildland that has been untouched by human habitation. The places that don't have a lot of people today are the same places as in the past. So no one's living in the Sahara Desert, no one's living in the Arctic Circle. Where you do see this huge transformation of the Earth's surface is intensification in places where people already have been for thousands and thousands of years. So you can take the same analysis and then break it down by the traditional biome. So this is, again, looking at the distributions of different anthromes over time in tropical woodlands, savannas, temperate woodlands, and so on. And again, what you can immediately see, for example, in the top left, that almost all of the tropical woodlands on the planet have been influenced by humans for 12,000 years. There is no such thing as a pristine jungle on the planet, period. And again, the only places that do have very little human influence over time are tundras and deserts. So again, places where people wouldn't want to live anyway at any point in time. You can also see this similar pattern in these lands targeted for conservation. So these are different, like the UN and different governmental associations have selected different areas that you want to target and protect from people's influence to conserve wildlife. All you need to know from this figure is that these patterns look exactly like the global pattern. That is, there's nothing special about protected lands or UN designated biodiversity hotspots that makes them different or pristine in any way from the rest of the planet. So the current day protected wildlife reserves has just as much of a long influence of human transformation as the rest of the planet. So we put all this information together in a web app that you can, with the help of Google, that you can go in and explore with. I can send this link around at the end of this talk. But this allows you to explore the data set and go back in time and look at different case studies. We have a little selector here so that you can zoom in on interesting historical facets. So here we can see what it looks like, the decline and fall of the Roman Empire, for example. So here we zoom in on Europe. And we can see, so this is this extensive cropland across Italy, the Mediterranean, that slowly declines with the fall of the Roman Empire. You can actually detect this signal in ice cores in Greenland. You can see that like lead pollution in the atmosphere measurably goes down when the Romans fall. Likewise, we can look at the classical Mesoamerican civilizations, so the Aztecs, the Inca, and the Maya, and how they grew and collapsed. So here, that red dot's current-day Mexico City. It was Teotihuacan. And again, we can see this massive transformation of the landscape with cropland and human habitation leading up into 1600, where everyone's killed off by smallpox and other European diseases. So you can just see the magnitude of that transformation. The amount of depopulation that happened here as a result of European diseases was enough to actually cool the planet, because so many people died, they abandoned their fields, and the forests actually regrew. This final one's just for fun. This is Florida over the last 200 years, or 150 years. And again, we can see how it starts off with this sparsely inhabited woodland. As we proceed through time, you can quickly see Florida urbanizing and becoming more agricultural and heavily populated. We're here in Gainesville up in that little hexagon cluster in the center there. And so you can see how quickly the landscape has been transformed. So now look how much of the Florida Peninsula is urban area, when only 150 years ago it was forest. So this exercise is extremely useful. It allows us to take all of this model information, put it in a way that we can map it out and better understand it. It's incredibly useful. One problem with it is that it's wrong, right? These are models. These are guesses about the past. We're using information in the present and trying to push that back in time. Of course, the further you push that information back, the more uncertain it becomes. One way that you can see this is if you break this analysis down by world regions. So you can see up in the top right here, we have Asia and Europe that have these really complex histories of human habitation. You can see here in Europe, you can see the effect of the Black Death, that drop in population, and everyone abandons their fields again. But if you look at these other areas like North America and Oceania, it's much simpler, and there is a lot less interesting history. And we're confident this is almost entirely because of the quality of the data. We have so much historical and archaeological data from Asia and Europe that we can really fill in these gaps over time. We just don't have that same kind of resolution in North America. So if we were to have more data, North America would look just as complicated as Europe. The other issue is that these modeling techniques that these teams in the Netherlands and elsewhere use are these top-down geographic models based on present-day data, and so they're really inflexible. You're basically using statistics at the country level and pushing that back in time. The side effect of that is that you can see like modern-day country boundaries in your estimates of where people were living thousands of years ago. A great way of seeing that is if you do this same analysis. These are two different data sets, by the way, that are supposedly of the same thing. And it just shows how massively they disagree with one another. If you look at the same analysis in the New World, you can actually see the border between the US and Canada 3,000 years ago. And that's entirely an artifact of using US and Canadian data and trying to push that back in time. So these models, they do a great job for what they're designed for, but they're not as flexible as what you'd want for understanding all of human history on the planet. And the final reason why we know this is wrong is that the archaeological data tells us that these human influences started so much earlier and were so much widespread, even than in these best guesses that I'm showing. This is another project we work on called Archaeoglobe, where we surveyed hundreds of archaeologists from the world and basically asked them, so you've been working in the Nile Delta for 50 years. When do you think, based on your experience of the archaeological record and excavating there, when do you think people started to transform the landscape and farm extensively? And so this just shows the number of contributors we had across the world. And so we tallied up their survey data for these world regions, and we can map that out in the same way. And so this shows these estimates of how widespread is foraging, hunting, and gathering. So again, this is not agriculture, this is mobile hunter-gatherers and how they were declining over time. The takeaway from this is that 12,000 years ago, most of the world was inhabited by hunter-gatherers, right? And we see this decline over time as agriculture becomes more predominant. It wasn't like 12,000 years ago, there wasn't anybody anywhere. The world was completely inhabited even back then. Likewise, you can map this out for extensive agriculture. And again, you can see the spread of agriculture from the centers of domestication in the Near East and South America, and how it very quickly spreads out to transform most of the Earth's surface. Similarly with pastoralism, so this is sheep, goat, and later cow herding, spreads out from these initial clusters in the Near East, very quickly covering most of the Earth's surface. And then finally, urban centers, again, the same story. You have very early founding of cities in the Near East and Mesopotamia that again expands outward at a really rapid pace. And likewise, what this tells us is that our view of the past is shaped by colonialism. That is, we have these top-down models that say the human transformation of the landscape was early. The archaeological data tells us it's even earlier than that. But then we know for a fact that the archaeological data themselves are biased. So another thing we asked the survey respondents was how many excavations were in each of these world regions. And so the places in yellow have more than 1,000 published archaeological excavations. So you can immediately see that we haven't really looked everywhere on the planet, right? That if you were to do 1,000 excavations in these parts of Africa or the Australian outback, you could potentially find just as many rich archaeological sites or cities or tribes as we do in these places like Egypt that we've intensively studied for long periods of time. So just going to look at two examples of that, one from South America and the other from the outback. So in South America and also Mesoamerica, places that are densely vegetated and have, even 50 years ago, archaeologists saw these were completely uninhabitable, that the vegetation was so dense you just couldn't hope to farm there. Now we can use new technology like LiDAR, which is basically like radar with lasers, that you can shoot through the jungle canopy and it reflects off buildings and structures that are otherwise totally hidden from view. So I think this is actually only a month old. This is a city that was found in South America. I think in Ecuador, or Honduras, where people thought it was impossible for people to live. You can see here the remains of giant platform architecture and these roads and causeway systems that go out for miles and miles and miles. And it turns out this kind of work, if you shoot this technology, this LiDAR technology at a given piece of jungle, you will find buildings, you will find cities across the Amazon, across the Maya region, even in places today where you might go like to Tikal, if you've ever been as a tourist, to Tikal, these major cities that we've known for hundreds of years. If you go there, you can still walk out into the jungle and find new buildings because the cities have sprawled further than we're even able to see. So that's on the one hand, but also we're finding out more and more information from talking with indigenous people and people who manage the land traditionally in the way that they and their ancestors have for thousands of years. So this woman is a forager in the Australian outback. The Martu is the member of the group she's called. And the women in this group hunt this kind of monitor lizard that grows in this grassland. And they will selectively burn the landscape in order to create the optimal habitat for this monitor lizard that helps them hunt it over time. And so they actively manage the amount of fire and vegetation over wide swaths of the landscape in order to harvest food. And these kinds of traditional land management practices have been happening for thousands of years. So people in the Aboriginal groups in Australia, they tell stories, these oral histories, that refer to mountains and landforms that have been underwater for 24,000 years, since the last ice age. So people like this are drawing on pools of knowledge of how to interact with and shape their environment that have been continuously transmitted from mother to daughter for thousands of years. And so these two tracks are just one of the ways that archaeologists are able to look at the much deeper and broader extent of human influence on the environment over the course of Earth's history. So this modeling exercise, it's wrong. We know for a fact that we're actually underestimating how long ago these changes were occurring, but it's still useful, right? We're able to map these patterns out in space, look at where we do know things, look at where there's still holes in our knowledge, and helps us understand these processes and target future research. And then one takeaway I want to have from this too is that even though we've shown this large-scale, long-term influence by humans, that's not an excuse for us to just do whatever we want now, right? We can't just say, well, the Amazon has been transformed by people for thousands of years, so who cares if we burn it down now, right? The other thing that this data shows for sure that we're certain of is that these recent changes we're seeing just in the last 50 to 100 years are completely unprecedented in our species history. So just look at the transformation of the continental US since 1800. So in about 100, 150 years, we have completely transformed an entire continent. This is not something that we've seen before. So just like the solution to these changes isn't just to get people off the landscape and go back to some imaginary pristine wilderness, the answer is also not to just let people do whatever we want, right? We have to find some middle way between those two extremes that helps us steward these landscapes for future generations. So the takeaways of these analyses are first that this idea of pristine nature doesn't exist, or it's rare, or the places that are truly pristine natural landscapes are the Sahara Desert, the Arctic Circle, places that no one would want to go anyway. Second is that cultural diversity is biodiversity, that the places in the landscape that have the longest histories of human occupation are very often the nicest places with the richest biodiversity and the most diverse landscapes. And so you can't just separate people from the places that they live. That in many cases, such as in the Australian outback, the entire physical landscape, the ecosystems, the animals, the vegetation you see there is the result of culturally transmitted practices for thousands of years. And then finally is that we need more flexible models of the human past. If we're thinking of the entire planet for 12,000 years, we can't just rely on the same kinds of methods that we use to talk about humankind today. And just a very brief teaser of this is the kind of work that we're doing moving forward, is instead of doing these top-down statistical models, we're trying to simulate societies of the past from the bottom up. So this is just a fun example looking at ancient Greek city-states. So we look at this little peninsula here in Attica, and basically we use the same hexagonal grid system approach, but instead we randomly put people across the landscape, we give them realistic environmental potential, and we allow these cities to grow naturally, totally independently of the data. So this is just based on first principles of economics and human behavior, and we can estimate where people might have been living and farming in the past, and then we can compare that to the real data. And that we can very precisely predict places where people are more or less likely to live in the past. And so we want to use these kinds of bottom-up simulation approaches to more flexibly model our human history on the planet. And so that's kind of the long-term goal with this kind of work, and why it's so important to do it here at the Florida Museum, is that we have so many diverse kinds of data about the human past. We have archaeological data, we also have genetics, we have plant data, we have all sorts of collections that we can collectively use to understand these processes so much better. And by combining this kind of modeling, this artificial intelligence, which is basically a way of integrating all these diverse data sets in a unified framework, we can really get at these questions in a way that no one has before. Well, thank you for your attention.
Questions, comments? I think most of the time that humanity's been on the earth has been since the last ice age. And it seems to me we're due for a second ice age, but it's global warming influencing that to an extent that we won't have one. And what will be the results of that?
That's been a theory that's kicked around for a while. It's kind of one of those theories that's hard to falsify. But yes, the idea is that if you look at the timing of oscillations of ice ages over Earth's history, is that we're kind of due for another one. Again, what does that mean? You know, it's something that's happening over millions and millions of years. Like, what does it mean to be overdue for something? But that's the idea, is that instead of having the Earth cooling off, we've seen it warming, and not just with recent global warming, but for longer than that. And one of the reasons that's been proposed for that is because of agriculture, and particularly like rice agriculture that I showed in the very beginning, because rice releases just a huge amount of methane. And methane's like 4 times more efficient as a greenhouse gas than carbon. And so these kinds of, cutting down all the trees in the landscape, planting all these artificial crops, it may have been enough to actually change the atmospheric composition in a way enough to actually slightly avert an ice age. That's kind of hard to tell now because we've now put so much CO2 in the atmosphere that like any signal of that is completely swamped out by what we've done recently. But yeah, it's entirely possible that we have been transforming the landscape like that. And people have been doing this even before the last ice age. But it's not through farming, it's through burning. So again, I showed you these hunter-gatherer groups use fire all the time to manipulate their landscape. And if you run these kinds of climate model simulations, even for the last ice age, they predict that you have a lot of forests in Europe, for example. But if you actually go into the soil and dig and you look for them, you don't find any forests. And so one of the reasons people propose is that people have been burning forests down for even longer than 24,000 years, for like millions of years. And so that's really where the cutting edge of this kind of work is just like how far back can you push that?
So in the beginning, you put up a statement that you were going to show us that the changes we see are neither recent nor destructive.
Sure.
And I get the recent part. That's interesting, how far back the changes go. But I didn't hear you disprove that I think humanity is a blight on our globe. And is that your next talk, or did I miss something?
I think it's more like you can't just cut this into a binary that people only do bad things. Definitely a lot of what we're doing now, especially urbanizing, so just paving over the environment is bad. But what we see in this kind of research is that in a lot of cases, these places, again, that we think of as being very biodiverse, so like the Amazon rainforest, one of the reasons for that is because the soil in the Amazon is actually the product of burning. It's like people burning their trash and their organic waste for thousands of years that actually is basically compost. So most of the Amazon has compost that has been created by humans accidentally for thousands of years that makes it more nutrient dense. And we see that in a lot of cases. So places that you think of as being very biodiverse are actually because of human influence. Another great recent example is in British Columbia, where you can go out into the forest and you see these little stands that have different kinds of vegetation, that have more and more diverse vegetation than the surrounding pine trees. And those are actually what we call forest gardens that were planted by the indigenous British Columbians like 300 years ago. And those forest gardens have continued on to the present day without human influence. So I think I like that metaphor of gardening, right? That yes, you can totally destroy the landscape, you can be destructive, absolutely. But also we can build gardens, we can maintain the landscape, we can be purposeful and responsible about how we interact with the landscape in a way to steward it much more continuously over time. And so time and again, especially in tropical environments, that's what you see, these evidence that people are actually enhancing biodiversity. In some cases, completely by accident, but in other cases on purpose, because you want to live, just like you eat. I'm coming from Phoenix in Arizona, where we have maintained the biodiversity by irrigating. You can go find lizard and mammal species on golf courses in Phoenix, but you never would before, that we're creating these new ecosystems. And so it's not inherently bad. That's not to say it's not always bad, but it's not inherently bad.
Okay, we have a couple questions here on Zoom. Paula, go ahead.
Yes, in one of your early slides, you were showing the increase in population beginning, I think, somewhere around the 1950s, where population was increasing pretty much exponentially. And then it looks like at the tail end of that, it's starting to level off a little bit. So one, I was curious, is our population not growing exponentially now? And then when you do your predictions, most of what you showed us was taking a backwards look. So when you model going forward, what does that look like?
Good question. So the first thing, so yes, global population has been leveling off recently, especially in places like Japan and Russia are getting older, much older population, and the birth rate is not outstripping the death rate. And this is a pattern we're seeing across the developed world. In part, it's because of increased education and access to birth control and things like that. But that trend has been getting worse and worse now in a way that some people are getting concerned about that global population will actually dip. Other people are happy about that because I think it's not great to have huge population. But that definitely is this empirical signal we've been seeing that the population has been leveling off. Basically, what you had in the 1950s, you had mechanized agriculture, you had the Green Revolution that allowed so many more mouths to be fed with the given amount of land that we have available. And that's basically, you increase the total population. In the last 50 years, we've come to meet that. And now some other technological innovation has to occur to raise the ceiling even further. For the second question, that's actually what we're doing right now, is trying to do this anthrome approach for the future and projecting it for the next 100 years. And the issue with that is that it's extremely sensitive to what people do. And again, this approach isn't very flexible. You kind of have to assume people are going to do one thing and then map that out. You can't have these dynamic interactions and reactions. So how do people vote differently, if there's a hurricane or a drought somewhere? We can't get at that. And so we're very dependent on these scenarios that people come up with that describe what the future is like. Are we just going to go business as usual, emitting the same amount of pollutants as we are now? Or are we going to try to decrease our footprint much more? And one of the things we show that even in the most extreme scenario, so there's this proposal called half Earth, which basically says we're going to give back half of the Earth's surface to to animals, to nature, and remove people from it. And even in that most extreme scenario, again, you're not giving back the Sahara Desert to what, right? Like the places where animals want to live are the same places people want to live, and that you can't just remove people from that. So even when you go into the future, you're met with these same questions and concerns. And again, so the solution is working together with nature. So how do we design the cities that we live in already to have a reduced impact? How do we alter our agriculture to be more sustainable? That's where the solution lies.
Thank you. Phyllis, go ahead.
Well, I'm just amazed at this technology. I read a lot of science, but I hadn't read about this. Obviously, I'm not reading the right disciplines. But so your technology is very useful. And as you can project forward, I wonder if it's possible to project backwards. For example, could we see Europe before Homo sapiens left Africa, debatably 100,000 years ago?
Yeah, and people are definitely working on that. It gets harder and harder the further back you go in time because the continents are moving and sea level is changing. And that gets really tricky. It's not as easy as just like raising sea level a meter and changing where the mountains are, because the Earth will actually change its shape when the weight of the water on it is changing. So as you go further back in time, mapping out these patterns in space becomes more and more difficult. But people are working on that. People are trying to simulate the climate of millions of years ago. There's a great project out recently that is looking at the meteor impact that killed the dinosaurs. So it's looking at the 10 years before and after and how that changed the global climate system in a very short amount of time. So people are doing this kind of work. Again, as always, it gets trickier the further back in time you try to go.
Thank you. And I can see in chat, one of our participants is asking for references for your papers. So if you send those to me, I can
Yes.
forward them on to this group. I'd be happy to. Any other questions here, John?
Questions from the audience here? I was in Tikal, the Mayan remnants of the Mayan civilization, and the story that they told there was that they collapsed not because of smallpox, but a combination of drought and soil depredation because of replanting the same corn in the same places year after year after year. Do your studies support that or not?
Well, that's this idea that the current state of the art is not flexible enough. Because basically what we do is take that information from the archaeologists and put that in the model, right? So this is what happened. But we do want to develop ways of trying to simulate this so that we can actually see how sensitive those cultures were. But that's the story you generally see, is that it's not just drought or climate change that causes societal collapse. It's not just environmental degradation. It's the intersection of climate change, environmental degradation, and political turmoil. So society becomes slow and unable to react to the changes that it's facing. And so that's what you see again. And then the case with the Maya is very interesting because yes, there was this massive collapse, but also like the Maya are still around. Like you can go to LA and people are speaking Yucatec Maya. Like they didn't disappear, right? It's just the government and the high level part of the culture that collapsed. And so this is these narratives that archaeologists are always dealing with. It's like, what does it mean for society to collapse? A lot of archaeologists now are understandably focusing on persistence. So like, sure, the government collapsed, but people kept on farming for thousands of years afterwards. I think the balance is somewhere in the middle, because I don't know if you'd want to be an average Maya citizen while your government is collapsing around you. Doesn't sound like a great thing to do. But it's always this intersection. So it's not just climate change, it's climate change and political turmoil, inequality. It's always a perfect storm. And the same thing you see with the Roman Empire or the Anasazi in the Southwest US. It's always the same story.
Are there more Zoom questions?
I don't see any other Zoom questions.
Any further questions here? Okay. Let's thank Dr. Gauthier once more for this very informative talk.
Thank you.
Next week at the same time, the second talk of the series will be given by Professor Jared Daniels, whose official title is Curator of the Museum Center for Lepidoptera. In more everyday terms, one of Dr. Daniels' jobs is the most popular of the museum permanent exhibits. And what would that be? Butterflies, right? The Butterfly Museum. The title of this talk is Building More Effective and Sustainable Landscapes for Butterflies and Other Pollinators. We think of bees. Here, we think predominantly of bees as being the pollinators. And of course, they are important pollinators. But it's important to recognize that also butterflies are important pollinators. So I hope to see you all again next week.